Alright, this is NET-200, Introduction to Computers, and it is from 11/9/16. We are in week 11. This was Wednesday. Alright, we talked about routers. Okay, so we have a router here, router here. Here we have a switch. Here we have a switch. Every one of these interfaces comes to a router. They all have to be on a different network. Interfaces that connect, like these two, have to be on the same network. So like this PC is connected to this network, so it has to be on the same network as this PC and this interface. This is another network over here. So let's take a look at these addresses. 192.168.11.0. Prefix 24, which means this part's the network. 8 bits, 8 bits, 8 bits. And that's an 11. And this network, come right down here, this is a 10. 24 again, so that means this part's the network, and this part is the host. Same thing up here, that's the host part. Okay? And so they are on different networks, right? Because that's a 10 and that's an 11. And then, for example, here it gives an address. That's a 10/24. The networks match, and then that's a particular place on the network, a 1. So when I address the PCs, I can't use 1 there. I have to use 2, 3, 4 on that network. This here is a network address. It has a 0 there, and this part's the network. If that was a 255, it would be a broadcast. This 24, in these cases, those are called prefix bits. Gives us a mask. Unicast is when we connect directly to another location. A very good example is you go to a website and it sends the information back to you. It's unicast. A multicast, you can send out information and then eventually it splits up and goes to various people. It's different than a broadcast that just goes to everybody. Alright, so if we were to look up here, this is a network, this in between here is a network, and down here is a network. Pretty good review. Then we went to IP6. Not enough addresses, and IP4, IP6. And then here we also talk about the prefix and the interface. We'll mention more of that a little bit. But we have these groups, right? We got 128 bits total. And then we have 1, 2, 3, 4, 5, 6, 7, 8. We write them in 8 groups so they're easier to see. Right? And so, right in here, we have F, 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 F as an example. The range of what these can be, they can be all zeros to all Fs. What does that mean? Well, we have to go back to base 16, right? We have base 16, or hexadecimal, so we have 0, 1, 2, to 9, and then for 10 we use A, 11 we use B, C, D, E, F for 15. How do you get 15 out of that? Get 15 out of an F, it'd be 5 ones. Okay? Or 4 ones, excuse me. 4 ones. And we're going to talk about translating those addresses. Now, in the movement from IP6 and IP4 to IP6, we can either run dual stack, in which we run IP4 and IP6 on the router, and it would figure out by just looking at the packets which one was which. We can tunnel, we can take one, let's say you have an IP4 network, you can take IP6 and tunnel it, use it as data, and then put the IP4 information on the outside. Nobody would know the diff. It would use the IP4 addressing. When it gets on the other end, we take this part off, and now we just have the IP6 tunneling. Translation, convert 4 to 6, and then convert it back on the other end. Not our best choice, not our favorite choice, even though those do work. Okay? But some equipment won't dual stack, so tunneling isn't a bad idea. A little more overhead. A few rules for writing IP6. You can omit leading zeros, and you can omit a whole segment of zeros, but you can only do that once. And the curriculum goes through and explains that. And we'll talk more of that as we go along. Now, previously on the previous slide, we talked about broadcast and so forth. In IP6, we still have unicast, one interface talking to another. And then we have a multicast. You send one packet and it ends up getting distributed to others. And then we have this anycast. Okay, it's kind of like a multicast, but it goes to the first one. We don't have a broadcast specifically in IP6. IP6, they talk about a link, and we'll refer to those subnets, and we'll talk more about subnets here next week. A couple key addresses we're going to talk about in IP6, global unicast and link local unicast. This is what you use locally for your networks, and this is what you would use out on the internet. If you want a comparison, public, private, even though they're not exactly that. All right. So we did a little work here. If you had this address and you needed to convert it, an F would be all ones, and E would be 1110, and 8, 1000, and a 00. What you can do for any hex, you can use this little pattern right here, and then just add them up. So if you had a B in hexadecimal, okay, a B would be 9, 10, 11, so that would be 8, 9, 10, 11. Would be a B. All right. We did some work over here. Again, we were talking about the network part of the address, host part of the address. We were looking at examples on the computer. This was the addressing of the computer I was on in class. 16 prefix bits. We worked on some conversion here, and we looked at the situation in the computer. You can't quite see that, but this PC has a default gateway, which is somewhere right inside that router. 172.31.0.254. I'll write that again. 172.31.0.254. An address in there, that's the default gateway here. That's the same, because that's the network part of the address. Alright, that's enough for today.